everybody. So my name is Melvin. I'm the principal product manager for ClickHouse core database. So I joined ClickHouse a while ago, like almost 4 years ago now. And today I'm going to talk to you about data warehouse. And I'm going to go through some of the history of data warehouse and how we build our own data warehouse, what type of improvement we did for ClickHouse to improve our data warehousing story. And hopefully that will answer a lot of your questions. And if you have any follow-up questions, please feel free to catch me in the other room over there. So when we look at back in time, like data warehouse is not a new thing, right? It's a pretty old topic, but it has evolved quite a lot. If we look at 30 years ago, for example, data warehouse relied heavily on licensing model, right? So you have to pay for this specific, I will say, instance type by the different type of license that you want to deploy on this hardware. And back then, data warehousing was kind of a big burden, very slow, very rigid in their format, and typically didn't really scale extremely well. And people tried to move away from this model. You can see, I don't know if you remember the good old time with Hadoop and Hive and all the things that people tried to do to go away from this, I will say, vendor locking mechanism and vendor locking data warehouse. But it didn't really stick around. What really stuck around was the next generation of data warehouse, which we call the cloud data warehouse, where we moved away from a model where you had to buy your hardware, your license, to just use a cloud service that was heavily relying on specific proprietary technology. And it helped a lot, right? So first of all, people moved from self-managed to cloud, but it also led to a better economic for the customers where they didn't have to pay for license, but they just pay for the resource that they were actually being using for their user. But still, this data warehouse were not really designed for extremely low query latency, and they had a few limitations. Most notably, they were heavily vendor locking, right, built on top of proprietary format for most. But now we see a big shift in the data warehousing space. We see the need for more real-time solution where people want to have very low query latency to power their real-time application. And that helped a lot. But they also want to move to more open format. We see it with Iceberg. We also see that people want to move away from proprietary format to more open format, on open source format like ClickHouse, for example. Today I'm going to talk to you about some of the advantage that people are looking for in their data warehouse. So the first thing that people are looking for is really about speed. So they want to be able to power their real-time applications. They want to know exactly where their customers are in their user journey, where their package is in their delivery, and so on. So people care about speed and having this real-time feed with their database. They also care about scale, because as people use more and more data, it leads to storage increasing quite significantly, and we see that overall the data volume increase everywhere, and your database is no exception. So your database needs to be fast, and it needs to scale. And they want flexibility. Historically speaking, databases were mostly built on top of tabular data, right? You need to have like this table and have like a very strict, I will say, table definition, but people want to move more into semi-structured approach. They want to be able to store more type of data. They want to store images, video, vectors, and that database need to be able to help them storing this type of data. And finally, they want to have efficiency without huge burden in costs. You don't want to spend your whole IT budget into a single technology. Your database needs to be efficient, both in terms of performance, but also in terms of cost. And this kind of summarizes our own story for our data warehouse and why we decided to build it on top of ClickHouse. So as you know, we are a cloud provider. ClickHouse is a cloud provider. We provide a cloud offering on top of ClickHouse. And we started our cloud offering in 2022. Before actually building this cloud offering, we also had to work with a lot of open source users. And when we created this cloud offering, we asked a lot of our cloud open source users, do you want to test our cloud? We are going to release a cloud offering. We would love to get your feedback about our cloud. And we had, I don't know, a few open source users that told us, yeah, sure, we would like to test it. And every day, basically, what we did is when we started releasing our database, in the cloud, we actually tracked all of the user in a spreadsheet. And that was our first data warehouse at ClickHouse. For each user, we actually tracked the number of nodes that they want to have, the regions they are going to deploy, when did they sign up to our cloud. And we kind of, every day with the support team, the sales team, with the engineering team, we were sitting around this specific spreadsheet and updating it row by row, going account after account, kind of keeping track of where were our user. But very quickly, this data warehouse was outscaled by our user and customers. Our cloud offering grew quite significantly, and we had to change our schema. So we moved to a different model where we wanted to store our data in a database, and we decided to use ClickHouse for that. And when we built the database, we really focused on what type of query we're going to receive. So we need to talk with all of our different users internally, our product team, our sales team, or operation teams that manage the cost of the company and so on. So get a feel of what type of data they need and what type of queries they're going to run. We had to gather all the different data sources that we had, and we started building our first data mart. And we stored everything, of course, in ClickHouse Cloud with separation of compute and storage. So we used heavily S3, and we used dbt and Airflow for the orchestration. And for our sources, we have many different sources. So first of all, we have all of our billing and measuring to make sure that we don't overcharge our customers or undercharge our customers. That goes into the data warehouse. We have the data from our cloud provider like AWS, GCP, and Azure that go also into our data warehouse. We have all of our marketing and CRM information that we have to stream into ClickHouse. So anyway, we have like all these sources that goes into ClickHouse, and on top of ClickHouse, we had to have our interface where people could actually communicate with this database. So we started with dashboarding because everybody loves a good dashboard. So we are using it for all of our use case internally to track some product adoption, to track our revenue and things like that. So we build we're using heavily supersets. So we build our dashboarding on top of superset initially. Some people want to have direct access to the database, so they can actually query it using the ClickHouse client directly or the SQL console. And we also want to facilitate reporting. So with this infrastructure, we were able to store around 2 petabytes of data. We are inserting around 1 billion rows per day. And we have, I think over 20 different sources that goes into ClickHouse. But there is one major flaw with this architecture, which is when you are a user when you are an internal user, you don't necessarily know how to write a SQL query, right? People, we have the sales teams that want to interact with our data warehouse to know what type of things their users are doing, but they don't necessarily know how to write a SQL query. So how do we make this data available to everybody in the company, regardless of their level of knowledge in terms of SQL? So we started working on something called Agent House, which is an LLM-based software that can plug to your data warehouse directly, and a user can actually, just type a natural language question, and automatically the LLM is going to convert into a bunch of SQL queries, interact with our database, and start generating dashboard and things like that to be able for users that can't write SQL queries to still be able to leverage our data warehouse. So how did we set that up? Well, we have our ClickHouse internal data warehouse with all these data sets that we are centralizing there, but we deployed on a separate EC2 instance or MCP ClickHouse server, LibreChat, which is the UI that you see where the user can actually type their question, which will interface with the MCP server and our LLM model, and then be able to interpret a natural language query and transform it into nice dashboards. So this is kind of how we went from a single spreadsheet to LLM-based data warehouse that can answer any type of question from our user. So that's kind of very interesting migration that we have done in the last 3 years only. So very interesting evolution. Let's see where we are in the next 3 years, but that's an interesting story. And as we build this data warehouse, we learn a lot. We also learn that some features are not necessarily ideal for some workload. And one of them was join. So when we created this data warehouse, often, I'm not part of the data warehouse team, but I'm working a lot with them. And they often give me this feedback like, oh, we need to improve this type of join and so on. So why are joins so important? Well, if you look at a table, in this type of table, you will see that there is often redundancy in your data, right? And if you have done any type of SQL classes at university and so on, you will probably know that we hate redundancy in database most of the time. Your teacher will tell you that redundancy increases your storage cost, it makes your ETL more complex, and it limits, it makes your query more complex as well. So typically, people will just explode their table into many different tables and do the join at query time. But it requires a good join implementation. So what type of work have we done at ClickHouse to improve our join story? So we support join for quite a while, but the last 12 months, we put a lot of effort into improving our joins quite a lot. So we wanted to make sure that we could support most of the possible joins, most of the possible join strictness, that we support various join predicates and join algorithm. And the results were actually quite impressive. So you can see this is 3 different releases that we have. 24.10 is around 1 year old, so it was an October release from last year. And this is on top of TPCH benchmark, which is a popular benchmark, and you can see that a lot of the query actually fail, run out of memory or timeout, or just don't run because we don't have a specific syntax. In May of this year, we actually made a lot of progress, and you can see that the performance improvement were around 20 times faster. And you can see that we don't have queries that time out. We added support for queries and subqueries, but we still add a few queries that run out of memory. And recently, we introduced global join reordering, which allow us to improve performance even more. And we actually see that now the performance are almost 50 times faster than they used to be. Great. So we can now safely say that joins are much faster than before. And the last part of the stack that we spend a lot of time on is around our lakehouse story. So when we designed ClickHouse, we really designed ClickHouse to be extremely fast and extremely performant on top of its own native format. And we wanted to make sure that ClickHouse was self-contained and that it has all the features that you need just on its own. You don't need to install other third-party software to get started with ClickHouse. So it's kind of the prerequisites that we had when we developed ClickHouse. But one of the main requirements that you have, and main challenges that you have when you're working with a database is actually getting data inside your database. So we spend a lot of time with ClickHouse making sure that you integrate with the rest of the ecosystem, with your Kafka queue, with your Redpanda, with your MySQL and PostgreSQL database, and also with your data lake. And historically speaking, our data lake support was kind of weak, but we spent a lot of time trying to improve some of the workflow. And the main workflow that we saw that people was using with Iceberg is that people use ClickHouse on top of their Iceberg table or Delta table to be a speed layer on top of their data lake. So basically, they do dual write both into ClickHouse and in Iceberg. And for their queries that require very low latency, they are going to send this query to ClickHouse directly. And to do that, what we have been doing is that we have been working a lot on improving our support for integrating with Iceberg directly. So we added support for catalog integration, for statistic, partitioning, pruning. So now we have Iceberg v2 compliance. We added support for time travel, schema evolution as well. And we also added a lot of feature to make it more native to work on top of Iceberg, including improving our Iceberg introspection. And we also recently added write support, which is in an experimental state. And we did the same work for Delta Lake, right? So the Delta Lake integration arguably was a bit simpler because we could leverage a library called Delta Kernel, which we don't have for Iceberg. So it was a bit simpler to do it for Delta Lake. But there is still a lot to do, right? We need to support Iceberg v3 that is coming up. We need to improve our support for Parquet Reader. So we recently added a new Parquet Reader in ClickHouse. We need to make sure that our write support is very good, so people can use ClickHouse to write to Iceberg directly without having to do double write, for example. And we also want to make sure that ClickHouse can optimize your table, your Iceberg table, so do compaction on top of Iceberg. And finally, there is all the work that we need to provide on top of a good cloud offering, so doing CDC pipeline from Iceberg to ClickHouse, for example, but also make ClickHouse a bit more serverless when it comes to working with Iceberg or Delta tables by being able to use stateless worker or integrate with our distributed cache. So there is still a lot of work that is going to come into Iceberg, and if you have any question about it, or if there is some specific features that you would love to see come in, feel free to catch me, and we can talk about roadmap.